This method can help researchers in the fields of biology, radiochemistry, and nuclear medicine to automate the production of short-lived positron-emission tomography tracers for basic research and clinical applications.
The main advantages of automating radiochemical synthesis are to standardize the synthesis process, to enable repeat production, to improve synthesis reliability, and to protect the chemist from radiation exposure.
By using a single flexible radiosynthesizer, multiple different positron-emission tomography or PET tracers suitable for clinical use can be produced within a single hot cell.
To ensure the success of the automated synthesis, it is critical to take great care during the setup procedure before the radionuclide is introduced into the radiosynthesizer.
To create an automated synthesis program for the PET tracer fluorine-18 labeled Clofarabine, or CFA, the precursor is first reacted with dried activated fluoride-18 to form the intermediate, followed by removal of the protecting groups to form the final compound. Use a paper and pen to divide the manual synthesis into high-level steps, and the high-level steps into discrete basic required processes. Then map each process into the individual unit operations provided by the synthesizer software. Using the radiosynthesizer programming interface, create a blank program by clicking Menu, Sequences, and New Sequence to program each of the identified unit operations and their parameters in sequence. For fluoride evaporation in Unit Operation 3, drag the evaporation operation to the film strip view and enter the reactor used, temperature, duration, and desired pressure of nitrogen stream. For precursor